Now let's talk about an infinite geometric series. The definition here says, an infinite sum with the first term a1 and a common ratio r is called an infinite series and is denoted by this sum here. So what we're going to get into now is we're going to talk about summing some of these infinite series up and actually getting some finite numbers sometimes. And it seems kind of weird because think about this. I'm adding infinitely many numbers together and I'm still getting something that's finite. That always seems strange to me. But anyways, that's the idea of what we're dealing with here. So for instance, take a look at this series. So if you take a look at this series below here, 1/2 plus 1/4 plus 1/8 plus 1/16 and so on, you'll realize here, or you might not realize this, but this actually equals a finite number. The sum of this is actually 1. So that seems strange in and of itself, but yes, if I add 1/2 plus 1/4 plus 1/8 plus 1/16 all the way down to infinity, so infinite many terms here, it equals 1. Now the way I would write this in terms of sigma notation would be, now this is our sigma, k equals 1 to infinity of 1/2 to the k. This is what it would look like. And if you think about this here, when I plug in 1 for k, that's where I'm going to get the 1/2 at. And when I plug in 2 for k, that's where the 1/4 is going to come from. So you can kind of see, well actually, so you can see that it's the same series. So now, with this in mind here, we know this is 1 as well, just because this is 1, and I told you it was 1. The idea is simple how this actually works. So take a look at this box here off to the, off to the right here. Now all we're going to do is just talk about this series here. So now if you think of this, let's take half of this. Now this half here would be all of this. So this is what we're going to keep and we're going to sum up. So now that would be the first term here. So now what I'm going to do is I'm just going to take half of that. Half of what's left there, and that's a 1/4, right? Okay, we can easily see that's a 1/4. So now I'm taking all this. Okay, and then from there, now I'm going to take half of that, and that's here. And then now I'm going to keep that. And that's 1/8. And then I'm going to take another half. And then I'm going to keep that. And then I'm going to take another half. And then I'm going to keep that. And then I'm going to do it one more time here. I'm going to take this half. And half of half of a half. And that's really what I'm doing when I multiply half every time. And then I'm going to take this piece here. So what we're seeing here is I take a half, and there's my first one. And then I take a 1/4, and that's this one. So, and I just kind of put some of the values in there for you to see of what's really going on here. And if you think about this, if I keep doing this and adding half, and then adding half of that, what we're going to see here is that this thing is eventually, when I get to infinity, going to equal 1. So this is a nice way for us to really see what's going on with these series with the 1/2. So that's the idea here. So we're going to talk about these series in general and when they can actually converge. Because when it goes to some finite number, it's called convergence. It's called this series converges. So we're going to talk more about this in the next problem.